Locking a motor control center is permissible under specific conditions, primarily when there are no exposed live conductors accessible within the enclosure and as long as the doors can be opened in an emergency from the inside. This practice aligns with established safety standards aimed at preventing unauthorized access while ensuring personnel safety during emergencies. Several factors must be considered to determine the legality and safety of locking a motor control center. Firstly, adherence to NFPA 70E, specifically Section 130.3b2 in the 2000 edition, addresses requirements for access to energized electrical equipment. This standard outlines conditions under which qualified persons can work on or near energized parts and the necessary safety precautions. While the standard doesn't explicitly prohibit locking enclosures, it emphasizes controlled access and hazard assessment. Secondly, NFPA 79, Section 12.11, provides guidelines for the electrical standard for industrial machinery. This standard focuses on the safety of electrical systems within industrial equipment, including motor control centers. It emphasizes the importance of disconnecting means and safe access for maintenance and operation. While NFPA 79 does not explicitly forbid locking MCC, it underscores the need for readily accessible disconnects and emergency procedures. Thirdly, the presence or absence of exposed live conductors is a crucial factor. If the motor control center is designed so that all live conductors are enclosed and inaccessible without tools, the risk of accidental contact is significantly reduced. This design feature supports the argument for allowing locked access to prevent unauthorized entry. Fourthly, emergency egress is paramount. Any locking mechanism must allow personnel inside the MCC to open the doors from the inside quickly and easily in an emergency. Panic bars or other emergency release mechanisms are essential to ensure safe evacuation. Fifthly, clear labeling and signage are necessary. The exterior of the MCC should be clearly labeled with warnings about the voltage levels inside, any potential hazards, and instructions for emergency procedures. This helps to inform personnel of the risks and how to respond in an emergency. Sixthly, training and authorization are essential. Only qualified personnel who have received appropriate training on the operation and maintenance of the MCC should be authorized to access the enclosure. This training should cover the potential hazards, safety procedures, and emergency protocols. Seventhly, regular inspections and maintenance are crucial. The MCC should be regularly inspected to ensure that all safety features are functioning correctly and that there are no signs of damage or deterioration. Maintenance should be performed by qualified personnel in accordance with manufacturer's recommendations. Eighthly, compliance with local electrical codes is mandatory. Local jurisdictions may have specific regulations regarding the locking of electrical enclosures. It is essential to consult with local authorities and ensure that all applicable codes are followed. Ninthly, a risk assessment should be conducted. A thorough risk assessment should be performed to identify potential hazards associated with the MCC and to evaluate the effectiveness of the safety measures in place. This assessment should consider factors such as voltage levels, potential for arc flash, and the presence of flammable materials. Tenthly, documentation is essential. Detailed records should be kept of all inspections, maintenance, training, and risk assessments. This documentation provides evidence of compliance with safety standards and can be valuable in the event of an incident. The National Electrical Code, NEC, provides a comprehensive set of standards for electrical installations. While the NEC doesn't explicitly address the locking of motor control centers, it does address general requirements for access to electrical equipment. Specifically, NEC Article 110.26 addresses spaces about electrical equipment requiring sufficient access and working space for safe operation and maintenance. Additionally, NEC Article 430 covers motors, motor circuits, and controllers, providing requirements for disconnecting means, overload protection, and motor control circuits. These articles emphasize the importance of safety and accessibility for qualified personnel. Another consideration is the type of locking mechanism used. A simple keyed lock may be sufficient in some cases, while more sophisticated access control systems may be necessary in others. The choice of locking mechanism should be based on a risk assessment and should consider factors such as the level of security required and the potential for unauthorized access. Regarding the 480 volts 3-phase Y configuration, it's important to understand the potential hazards associated with this voltage level. A 480 volt system can deliver a significant amount of energy in the event of a fault or arc flash, posing a serious risk to personnel. Therefore, it's crucial to implement appropriate safety measures such as personal protective equipment (PPE) and arc flash protection to mitigate these risks. Proper grounding is also essential to ensure that fault currents are safely diverted to ground, minimizing the risk of electric shock. The grounding system should be designed and installed in accordance with NEC Article 250, which provides detailed requirements for grounding and bonding. In addition to the technical aspects, it's also important to consider the human factors involved in the operation and maintenance of motor control centers. Proper training and communication are essential to ensure that personnel are aware of the potential hazards and how to respond in an emergency. Clear and concise procedures should be developed for all tasks performed on or near the MCC, and these procedures should be regularly reviewed and updated. Furthermore, it's important to foster a culture of safety in the workplace. This includes encouraging employees to report potential hazards, providing them with the necessary training and equipment, and recognizing them for their contributions to safety. A strong safety culture can help to prevent accidents and injuries and improve overall workplace safety. The specific requirements for locking motor control centers may vary depending on the application and the local jurisdiction. For example, a motor control center located in a hazardous location such as a chemical plant or refinery may have more stringent requirements than one located in a general industrial setting. Similarly, a motor control center that serves critical equipment, such as emergency generators or fire pumps, may have additional requirements to ensure reliability and availability. To ensure compliance with all applicable regulations and standards, it's recommended to consult with qualified electrical engineers, safety professionals, and local authorities. These experts can provide guidance on the design, installation, and operation of motor control centers, as well as the specific requirements for locking and access control. In summary, locking a motor control center is permissible under certain conditions provided that all safety requirements are met. This includes ensuring that there are no exposed live conductors, providing emergency egress, implementing appropriate safety measures, and complying with all applicable regulations and standards. Regular inspections, maintenance, and training are also essential to ensure the ongoing safety and reliability of the MCC. By following these guidelines, it's possible to balance the need for security with the need for safety, protecting both personnel and equipment.